Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrill's Algebra 2 class. Today we're going to continue with our ratios and proportions lesson on 3.4, okay, guys? And last time we left off, we were still learning how to work with and solve proportions. So now I went ahead and just complicated it just a little bit, okay? Whenever we have proportions, remember that that's two equal ratios. So all we've got to do is cross multiply to solve. Very good, my brothers. So we're going to go ahead and cross multiply. Now, I need you to really pay attention to this because I'm multiplying my 5 times x plus 5. But please remember that that is inside of a parenthesis. And that equals 4 times x minus 8. So what property do we have to use here before we start solving, Yordi? That's it. So let's go. We got 5x plus 25 equals 4x minus 32. Okay, what do we do now? What do we do? What do you think we do? Ah, that's my boy. Yes. All of you were right. Okay? We just didn't have anything to do yet. We had to combine like terms on both sides. That's already done. So after that, you got to get the x's together. Great job, my brother. So I'm going to subtract 4x to both sides. And that's going to give me x plus 25 equals negative 32. Now we're left with a single step equation. So what do we do now in this single step equation? What do we do, my brother? You subtract 25 because I want to get x all by itself. And that's exactly right. X is going to equal negative 57. And that's how you do that. Does that make sense, gentlemen? Okay. Any questions on proportions so far? All right, let's do some application now. How many of you guys have ever used Google Maps? Yeah, exactly. Or a GPS? Or Waze? Or any type of digital map? Okay. I'm going to show you today how they calculate all of these distances. The GPS works really cool, you know. Apple Maps, Google Maps, all that's awesome. But it all works based on scale. And scale is just another type of proportion and ratio. So let's talk about that, guys. When we're talking about scale, okay, scale is a way to write or draw, rather, really large objects in a way that we can read them, or very, very, very small objects in a larger way that we can read them. For example, this is a scale drawing of the United States of America. This is not the actual size of America. We know that. But it is a scale model. How many of you guys, by show of hands, have ever seen a globe? Okay, all of us have seen a globe, right? Guess what? That's a scale model of the Earth. There's no way for us to really look at where China is on Earth by looking at it in real size, right? We'd have to go up into space. And I'm not trying to be sarcastic. I'm trying to give you guys the power of scale. How many of us, when we were kids, come on, don't be ashamed, had little Hot Wheels, little toy cars? Yeah. Did any of you ever turn it over? Did you notice that it said something like, I remember at least back in my day, it said something like, whoa, 1 and then colon, and then it would have a ridiculous number like 57,000. Did you guys ever, by chance, look at that? Well, that's the scale of the model. What that meant is, hey, look, dude, for every 1 little inch, let's say, on your toy model, it really means 57,000 inches on the real model. That's what a scale tells you, okay? Now, I know that, again, you guys work with GPS, and I get it. But I need you guys to understand how that GPS works. Back in my day, I used to have something called a key or a legend on a map. They still exist. They're still around, okay? We're not done, right? Okay, I was going to say, no, I have so much time left. All right, so what happens here is we used to have a key or a legend. And I went ahead and made one for us called this scale. Now, what the scale tells you is, hey, on this map, every 1 centimeter equals 35 miles in real life. That's what a scale is, guys. So what did I do? I took this scale model of the United States. I took a legitimate, real, this is a true metric ruler, guys. Okay, this isn't an illusion that I'm trying to mess with you. This is a true conversion here that I did, okay? Now, and actually, look how cool this is. I can go like this. Actually, all right, watch. And then when I hit enter, oh, it gives me my, well, that messed up. I don't know why I went to there. I don't know why I did that. Hold on. Ah, that's why. Okay. There we go. From that arrow to that arrow, and it gives me my 9.5. Pretty cool, right? All right. So anyways, that's neither here nor there. That's a tool. Okay, guys. So I have 9.5 centimeters, not because Mr. Morrow says so, but because that's what the metric ruler says, okay? I'm just trying to be as accurate as possible. I want you to see how it is that things calculate. So in my actual real metric ruler, I found the distance from, let's say this is Miami, and that's a little bit north of California, of LA. So I'd say maybe like Visalia, California, okay? I want to find the actual distance between Miami, Florida, and Visalia, California. Yes, sir. Well, I'm not even going to answer that. I'm going to set up a proportion. I'm not trying to be rude, but I want you to see the power of proportion. Remember that when we were talking about setting up proportions, you first have to write down the fact ratio, right? What is the fact here, my brothers? What is the fact? What fact do you know? Yeah, that 1 centimeter equals 35 miles. What am I looking for here, brothers? The actual distance, right? So, remember what I said. Unit to unit, unit to unit. So what was I given? Was I given centimeters or was I given miles? So I'm going to put unit to unit. There it is. That's my boys. Over X miles. Does that make sense, gentlemen? You promise me? Okay. Now, let's go ahead and cross multiply. So when I cross multiply, I got X miles centimeters equals 35 times 9.5, 4. So that's 521, 3,330, 3,325. But then I got to move the decimal. Aye. And then I got to move the decimal once that, so 332.5. No, that can't be right. Yeah, okay, 332.5 miles, and that's wrong. 332.5 miles, that's wrong. It's way more than that. Okay? But if that was, remember, I just made up a scale. This is inaccurate not because of the ruler or because of the map. It's inaccurate because of my scale. I just made up this scale. If that was the scale, that was it. It would probably be more like 70 or 80 miles for this scale, for this rate. Yeah, we need to get another tenths, yeah. So yeah, 350, exactly, yeah. Okay, but that's what your Google Maps does. That's what your GPS does. There's a scale built in within it, and it starts calculating, and it figures it out. That makes sense, guys? So a scale, again, guys, is really important because a scale Because a scale allows you to show models of different sizes. And that's the important part. Look at that pretty little cruise ship there. Can you imagine the real size of a cruise ship? I could never show you guys anything about a cruise ship unless I took a picture of it. And then again, all a picture does is what? It makes a scale model, but in a visual sense, right? So scale is very, very important. Does that make sense to everybody? Okay. May I continue, my brothers? Okay. Thank you. So let's continue. Let's go ahead and look at this situation. So I got, you good, Mama? All right, my brother. If the scale model of a car is 1 inch to 6 feet, find the actual length of a model car that is 3 inches long. Who wants it? Who wants to try this one? Come on up. Let's go. Come on, you're live on film. Don't embarrass us. No, I'm just kidding. No pressure. Let's do it. First things first. Let's see what he gets. Oh, sorry. Yeah, you got to. There you go. Okay, so first thing he's doing, he's not telling you guys, but he's writing down the fact. This is the fact that we know. That 1 inch on this scale model equals 6 real feet. Okay, now we're going unit to unit and unit to unit. So we're looking for 18 what though? X is what? What are we looking for? There you go, my brother. Excellent. Make sense? Yeah. Awesome. Now, I'm confused with what you said. Don't I have to make them the same value? I didn't get that. No, why would you do that? Why would you do that? No. Because we're looking for an actual length, my brother. And the scale here is 1 inch of the model, right, to 6 feet of the actual. If you go ahead and start manipulating this 6 feet into inches, you'll still get the right answer, but now you're going to have the actual answer in inches, and you're going to have an exorbitant number of inches. Does that make sense, my brother? If I had 18 feet, now I got to multiply that by 12 to express it in inches. What you're thinking about is if I said, find the ratio of 1 inch to 6 feet. Okay, that's not a ratio. That's not a ratio because they're not the same units. Now, in this case, I can say this is 1 inch to go ahead and say 72 inches. Now that's a ratio. Do you see the difference, my brother? Great question. Yes, sir, my brother. This is what he did. He cross-multiplied. Yes, sir, because when we saw a proportion, we literally just cross-multiply. How did he know it was feet? Because you labeled properly at the beginning. Does that make sense? Promise. Okay, let's go a little bit further. Okay, similar figures. You may say, wait a second, Moro. We already had enough of this already in geometry. Yeah, I get it, but that's why you learned it. Because in geometry, you learn this because there's going to be different uses for this. So let's go back in time, guys. A similar figure. A similar figure, first of all, must have the same shape. Okay, you got to have the same shape. If you don't have the same shape, you don't have a similar figure. But they're going to be different sizes. If you have the same shape and the same size, then what you have is a congruent figure. The corresponding angles are equal, and the corresponding sides are proportional. Okay? So let's first take a look at remembering how to find corresponding angles and corresponding sides. Okay? Which are the corresponding angles? Well, you never, ever, 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 ever look at the figure. You always look at the statement. So this statement right here, very important. Bless you, my brother. Okay? This is a very important statement. You read from the statement. Angle A corresponds to angle D. And they're congruent because corresponding angles and similar figures are congruent. Angle B, which is the second letter, corresponds to E. because it's the second letter. So angle B will be congruent to angle E. Okay? Does that make sense? And then, last but not least, I've got C, which is my last letter. My last angle corresponds to my last angle, F. So angle C is congruent to angle F. Does that make sense, my brothers? Now, corresponding sides. Okay, again, you read from the statement. Please, guys, never the figure. And why do I say never the figure? I'm going to show you right now. Let's say I take this guy, right? And I go like this. Wouldn't it be tempting to say that A is corresponding to E? Wouldn't that be tempting? That'd be wrong, but it'd be tempting, okay? So you got to be careful with that. Please. Okay, so now as far as the sides go, it's the same thing, y'all. Same thing. Go by the statement, not by the figure. So for example, the first one I have AB is going to be proportional to DE. So AB to DE must be proportional to now BC to EF, and that must be proportional to AC, the first and the last, to DF, the first and the last. So that does not mean that these sides are equal, not all. It means they're proportional. What are you talking about though, Moro? Let's say that I had this was 4, let's just say for giggles that's 5 and this is 6, just for giggles. Okay? And then I say that this is 8, 10, and 12. My brothers, AB to DE is 4 to 8, correct? BC, which is 6, corresponds to EF, which is 6 to 12, correct? And AC, which is 5, corresponds to DF, which is 5 to 10, correct? Are these proportional? Absolutely. Of course they're equal. That's a half, that's a half, that's a half. So they're all proportional. Does that make sense? Thank you, my man. Yes, sir, my brother. Okay, the question was, is that always going to work like that? When they're proportional, yes. When they're similar figures, yes. If I gave you two figures, let's say I gave you this. 8, 9, 10, and then I gave you 4, 3, and 5. Okay? And I said this is A, B, C, and D, E, F. So we're not going by the figures. We're using this same correspondence, okay? AB goes to EF. EF, I'm sorry. I'm sorry. Yeah, AB goes to DE, rather, sorry. BC goes to EF. Are those equal? And AC goes to DF. Are all of those proportional? No. This is 2, this is 3, this is 2. So are these figures similar? No, they're not similar. But yes, if they're similar, the corresponding angles are congruent and the corresponding sides are proportional always. Are you with me, sir? Is everyone with me here, my brothers? All right, now let's see how this is used in real life. Okay, find the value of x. Okay, now, I kind of messed up here, okay? I just finished telling you you can't go by the figures, but I didn't give you a statement, did I? I will never do that to you on the quiz. So let's go ahead and say that triangle ABC is similar to triangle DEF. Now we can do this properly. Okay, I want to find x, okay? So I'm going to have to set up a proportion, guys. So what's one fact that you know for sure that we can fill in right now immediately? Yes, sir. 8 to 4, okay? So we've got AB to DE. What does that have to equal? No, that has to equal AC to DF. It has to equal AC to DF. Remember, guys, the ratios of the sides are proportional, okay? So now let's go ahead and cross multiply. We've got 8x equals 40 divided by 8, so x equals 5. We're done. Does that make sense? That's it. Similar figures. Now, there's another way to do this. Let's say you don't get that way. How about this? Maybe this will help you. Don't I know that in this triangle here, 8 to 10 is in the same triangle, right? 8 to 10 equals. Who relates to AB? DE, which is 4. Who relates to 10? Cross multiply. Either way, what you have to remember is that the sides, corresponding sides of similar figures are proportional. Does that make sense? Does that make sense? We're good? Now, okay, great SAT question. Great SAT. I see some of you laughing at my little drawing. I did not draw that. Okay, I found it. All right. So a man that is 6 feet tall, okay, casts a 4-foot shadow at the same time of day. That's very important. A lot of times people don't realize this. It's very important for them to say it's the same time of day. Because as you know, the sun, right, is moving. Well, we're moving, right? Sun rises, sun sets. So at different times of the day, the angle of the sun will vary. It's going to change. So I have a man that is 6 foot tall, casts a 4-foot shadow. At the same time of day, a tree casts a 30-foot shadow. Find the height of the tree. This is SAT, ACT to the max. Set up 2 similar triangles. We know, my brothers, that this gentleman is 6 feet tall. We know that. We know that. And we know that he casts a shadow that is 4 feet. So I just made a little triangle. Does everyone see what I did there, my brothers? Now, why did the shadow go this way? Remember, the sun's this way, right? So the rays are catching there. So the shadow is going to be produced there. You with me? Okay. Now, I want to find the height of the tree. Well, at the same time of the day, the tree has a height. Do we know the height? What do we call something we don't know the height for? Oh, yeah. And now, what's the shadow of the tree, though? 30 feet. Guess what, guys? I just created 2 similar triangles. And now, how do you think we're going to solve this sucker? Yes, sir. You don't even have to label at this point. I'm very proud of you, but isn't this the height? Isn't this the horizontal? So x to 30 must equal 6 to 4. Why did you put 6 there, my brother? Now they're all the same units. They're all in feet. But it's the same corresponding side, right? You've got a height to height. And then you've got the shadow length to the shadow length. Does that make sense, brothers? So let's go ahead and cross multiply. So I've got 4x equals 180 divided by 4. And x is going to equal 45 feet tall. And that is my tree's height. Does that make sense, brothers? Any questions at all? We're good? You promise? Yes, sir. You want me to redo this? Oh, okay. Okay. What my boy was saying was, can't I just go directly to the equation? Okay. The technical answer is yes, of course. You can go ahead and just go right to the equation, but do I like that? No. Not because you can't handle that, but because I want you to become very fluid with it. So the more you visualize what's going on, guys, oh yeah, height to height, shadow to shadow. I'm very proud of you for recognizing that, and I would not mark that wrong on the test. But, there could be more complicated problems in the SAT or ACT. So if you learn how to model it when it's easy, it becomes easier to model it when it's difficult. Any other questions on that, my brothers? Going once, twice? All right, sold for $1. And bada bing, bada boom. Thank you so very much, guys. I hope you had a great lesson. Hope you learned a lot. And have a great day. Bye-bye now.